capai misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam, Sejahtera, and good evening, everyone. Welcome to Pusat Tuisyen Akademi Youtuber with joint venture of EDDET Malaysia and Guru Malaysia. So I'm Mr. Peh. Currently, I'm teaching at College Tingkatan 6 Fatimah, Melaka. I am the teacher on duty for this week. And for information, we have two classes of physics in this week. So where the Form 4 class will be presented by teacher Slinda, and they are in subtopic of 3.1. Okay, so hukum kegravitian semester Newton. And the class for Form 4 will be held on every Friday. So 9:30 p.m. is for Non-DLP, that means it's using Bahasa Melayu. So another class will be as today, so will be Form 5 Physics for DLP. Okay, so I will be going to use VN and English for my teaching today. And the class for Form 5 will be at every Sunday, 8:45 p.m. Okay, so today we are going to continue our last subtopic of Chapter 3. So there is Chapter 3, Electricity, with a subtopic of 3.4, Energy and Electrical Power. Okay, and the lesson for today will be expected completed within 1 hour. And for information, the e-sigil link will be provided at the end of the class today. And please fill in the link within 30 minutes just after the live finish. And you can fill in with any email available from you. Okay, so without further ado, so let us start our lesson today. Okay, so for today's subtopic, we are going to learn about 5 learning standards. Okay, so the first learning standard, you need to know the relationship between the electrical energy we're using the symbol E, voltage V, current I, and time. Okay, so that means here you will be learn the related formula to solve the problem solving where you are going to see the question at learning standard 3. Okay, so electrical energy is the energy supply by a source of example here will be dry cell battery to all electrical component connected in the circuit. Okay, so that means the electrical energy is provided by the sources, example dry cell and battery, so that the electrical component can be functioned because of the presence of electrical energy. Okay, so the electrical energy provided can be converted to heat energy, light energy, kinetic energy, and sound energy. So this depends on what type of electrical appliance you are going to use. Okay, so hi, Jimmy. Okay, so see you again. So welcome to my lesson. Okay, so you can also share your answer. Let's say we are going to discuss the checkpoint later on. Okay, and then the relationship between the electrical energy E, voltage V, current, and time will be here. So for the discussion of the relationship, you need to understand 2 definitions here. Okay, so the first is regarding of the potential difference with symbol V. So the potential difference across 2 points is defined as energy dissipated or transferred by one column of charge with symbol Q, okay, that move through the 2 points. So this will be the formula you actually already go through at section subtopic of 3.2. Okay, so V equal to E over Q. If I say we explain through this definition, okay, then the second, there will be the current with symbol of I is the rate change of rate of charge flow. Okay, so equal to Q over T. So the charge will be with symbol of Q. Rate, that means per time here. And you can rearrange to become Q equal to IT because you need to substitute Q in the first definition with IT. Okay, so they will be like this. Q equal to IT, and then you substitute to the Q in the first definition where will be V equal to E over Q. So that the equation will become E over IT. And then we rearrange again because you want to get the equation where, okay, so where will be E in terms of VI and T lah. Okay, so after you rearrange, you get your first equation. So E equal to VIT. Okay, and the formula will be going to apply at lane center 3. Okay, so the next, so the SI unit for electrical energy is joule. So since this is energy, so the unit will be joule. Okay, and then from the equation just now we just derived. Okay, so the 1 joule, okay, 1 joule is the electrical energy that transferred by electrical appliance when 1 ampere of current is flowed through it with potential difference of 1V for 1 second. Okay, so you can just using the formula, okay, we just described just now to get the sentence of number 4. Okay, so for Ohm's law, where V equal to V equal to IR. So from equation number 1, so you can substitute the V value as IR, which is Ohm's law. Okay, and then you can get the second equation. Okay, will be like this. IR substitute into V, then you get the second equation, I square RT. Okay, so then there is another formula you can get by rearrange again the Ohm's law, where I equal to V over R. And then we're using the same formula, the first formula, E equal to VIT. Then we substitute our I with V over R. So you get V square T over R. So with this equation. Okay, so this is 3 equations related to E with V, I, T, and R. So for the first equation, is actually without R. Then for the second equation, is actually without V. Then the third equation is actually without I. Okay, so the second one without V. Okay, so the formula which you want to choose for your application, this will be depends on the question. Okay, so we want to see what's the information given by the question. Okay, so now we go for Learning Center 2. So for Learning Center 2, you'll be learn the formula of the relationship between power, voltage, and current. Okay, so here that means you want to get again the formula where P in terms of V and I. Okay, so let us see the definition here. The power is defined as rate of electrical energy dissipated or transferred. So you get this formula. So energy will be E, and then the rate will be over T. Okay, so this will be the first equation where we relate the P, E, and T here. Okay, and then from the equation we get just now, we derived just now, where there will be E equal to VIT. So we substitute the E with VIT. Okay, so you get P equal to VIT over T. Then we can cancel out our T. Okay, so that we get our relationship for the second equation, where P equal to VI. So that means the relationship P, V, and I can be derived by using this method. And P will be directly proportional to V and I here. Okay, so hi Putri. Okay, so thank you for joining my lesson. Okay, so then the next, the unit SI for power, there will be watt. Okay, and then from the equation number 1 just now, we using a definition of power. Okay, so P will be equal to E over T. So besides the unit of watt, you can actually using energy, the unit will be joule per second. Okay, so that means another unit SI for power can be joule per second. Okay. Okay, so from the formula, this formula, so 1 watt is the power of the electrical appliance which can produce 1 joule of energy in 1 second. Oh, so you can get the definition of 1 watt by this first formula we derived just now. Okay, then the second formula we also derived already just now. Okay, so where will be P equal to VI? So you can form the third equation of P. And this formula will be going to apply at subtopic, learning standard 3 later on. Okay, so from Ohm's law, V equal to IR. So that means the V from the second formula, we can substitute with IR. Okay, so you can see P equal to VI, and V is substitute with IR, where it come from Ohm's law. So we get the new formula of P will be I squared over R. Okay, again, the Ohm's law can be, okay, so here the formula P equal to I squared R is mainly used to calculate the power loss in the electrical wiring system. Okay, because the power loss is depends on the amount of current flow. Okay, so when the higher the current flow, so the energy will be lost in terms of heat. Okay, so the power loss will be increases lah. Okay, then the second here, we can rearrange our Ohm's law to become V equal to V, I equal to V over R. Okay, so you can get the fourth formula for P. So you can substitute the I into the second equation again here. Okay, so the I can substitute as V over R. So you get your new formula equivalent to V squared over R. Okay, so the formula is used to calculate the resistance of the electrical appliance from its power rate when it functions. Okay, in simply said that you can see again. So the second formula here is actually without resistance value. Okay, then the third equation of P here is actually without voltage now. Then the fourth equation of P here is actually mainly here will be without the current. Okay, so you have to choose the appropriate equation for your learning center tree. Okay, so here we are going to discuss the learning center tree. Okay, so the learning center tree will be the problem solving involving electrical energy and power in daily life. Okay, so here the problem solving involving electrical energy will be three equations. And the learning center one, just now I show you how we get these three equations. Okay, so will be E equal to VIT, V equal to I square RT, and V equal to V square T over R. And then the problem solving related to power, we have four. I also show you how we derive these four formula already. The first formula we form is definition, right? So where the power is the rate change of the energy. Okay, then the equation 2 we using E equal to VIT, where substitute into the V and we get the second. And then third and fourth we using the Ohm's law. Okay, in case you forget already the formula, you can just using the definition of the power with the VIT, E equal to VIT. Okay, and then using Ohm's law to derive others equation. Okay, so here I want to discuss together with you. Okay, so the problem solving related to equation of E and P here. Okay, so you can show your answer in the chat room. Okay, so that I know that you are learning together with me here. Okay, so the first will be the meanings of the 60 watts. Okay, so watts will be the unit for power. Just now we already discussed at learning center 2. Okay, so the definition I also explained already just now. Okay, so there will be rate of energy, rate of the electrical energy dissipated or transferred here. Okay, so that we need to choose the answer related to energy, right? Okay, so you can see the answer is very clear. There will be B, right? You see the rate change of energy is 60 watt. So for the first one is power. So definitely it's wrong for definition of the power. And also C and D, the voltage and current is wrong. So we need to choose the terms of energy. So answer is very clear. There will be B. Okay, good. Okay, so Jimmy, show me the correct answer already. So good try for Jimmy. Okay, so hope that you can together with me here for more question discussion here. Okay, so for question number 2, okay, so you can show me your answer in the chat room, so that I know you understand what I'm teaching here. Okay, so the question will be like this. This is a question from SPM 2006. Which graph show the relationship between the power and the square of the current? Okay, square of the current of a wire with constant resistance. Okay, so here the tips will be the third formula just now we learned through the learning center tree. So where P equal to I square R. Okay, so here again you can arrange the formula in the format of straight line equation. Okay, so where will be Y equal to ms plus C. Okay, so the graph Y is P, and then the SZS will be I square. So that means that the gradients is actually represented by resistance. And here, this will be 0, right? So that means the C is equal to 0. Okay, so what is the correct answer? Yes, good, Jimmy? Okay, well done, So answer here is A, Okay, so answer is A. So the graph is a straight line passing through origin, Okay. So answer is A, good. Okay, and then the next, okay, so question number 3 is a question from 2006 on. Okay, so you can using your calculator and try to solve the question now. Okay, so diagram 26 show an electrical circuit. The reading of ammeter is 0.2. So that means you can just using a symbol I equal to 0.2. Then the reading of voltmeter V equal to 2.8. Okay, so calculate the electrical energy release by the time of 2 minutes. So T will be 2 minutes. So here you have to make sure that your time change to SI unit. Okay, so here, what is the equation can be used for solve this problem? Okay, so electrical energy we're using symbol E. So that means we have to find E related to I, V, and T. Okay. Okay, so here as per discussion just now, the question given us already, the current 0.2, volt be 2.8. Okay, and then time will have to change to second times 60, you get 120. Okay, so the equation you have to choose, there will be E equal to VIT. Just now we learned already. We have, yes, good. The equation here, we need to choose VIT. Very good, Jimmy. Okay, so you substitute all the value. 2.8, 0.2, 120. Okay, so what should be your answer? So you may show me your answer in chat room. Okay, so all the answer is actually provided. The information is actually provided already. So you just need to press your calculator. Okay, so the answer should be 67.2 joule. Okay, so very clear that the answer will be D lah. Okay, so I think should be no problem to solve this question, right? Okay, so let us go to our next question, number 4. So the question is from 2012. Okay, so here, the amount of electrical energy converted into heat energy. Okay, so you can just look at the symbol. So the unit joule, this will be represent as E energy. Okay, then when a current of 0.4 ampere flow through the wire for 10 seconds. Okay, so always use a symbol. Okay, for the parameter, so that you know which formula you are going to use now. So here T equal to 10 seconds. Okay, so what is the potential difference across the wire? So the question need to find out V. Okay, so actually you have many methods to solve now. Okay, so here, question given us the value where I already discussed just now. Okay, so from here, again, we're using E equal to VIT now. Okay, so you just rearrange your first formula, V equal to E over IT, or you want. So in the, yes, good. Okay, using V equal to V over IT, okay, so Jimmy, very good, well done. So other students also may show your answer in chat room together with me here. So here you just substitute E as 2, then the I 0.4, okay, and then the T will be 10. Okay, you just press calculator, then you can get your answer ready. Okay, so the answer should be 0.5 volt. Okay, so answer will be A. Okay, good. Good try, everyone. Okay, and then the next question here will be the question number 5. So the question is actually the actual question of 2011. Okay, so here we have a diagram. Shows the electrical circuit. Okay, so the question asks you to find the power dissipated. Okay, so power dissipated, that means we need to find P. Okay, so here we can actually again here we have many method to solve the question. So the question given us the resistance and also the voltage. Okay, so why is the power dissipated? Okay, so here you can using actually P equal to I square R. Okay, because we want to find the R, the I first. Okay, so the I can be find through the Ohm's law lah. Okay, using the Ohm's law, V equal to I equal to V over R after we rearrange lah. Okay, you substitute the value of V and R, you get the current will be 1.2 ampere. Okay, then you can just substitute into the equation I squared over R. So I is already get, and the R is 5. So I square R will be get, the value here will be 7.2, which is C. Okay, power I squared over R. Okay, so Jimmy, your equation P equal to I squared over R should be, okay, you can using another formula. Yes, V squared over R is correct. Okay, so V squared over R can be used also. Okay, so how we get the formula just now, we also try together. Okay, so let me solve the equation suggested by Jimmy. Okay, so V squared, V is provided 6 squared. So over 5. So there will be 36 over 5. Okay, correct. So 7, 5 will be 35. Yes, 7.2 lah. Yes, the answer is the same also. So that means you can actually use many ways to solve the question here. Okay, so here the next will be the question number 6. So this will be the last question for learning standard 3. Okay, so we have another learning standard 4 and 5 after this question. So the SPN question of 2013 will be like this. Okay, so here this will be a little bit different from the previous question. So where here we need to solve the resistance. Okay, so where is arranged in series actually. Okay, so what is the heat produced? So heat energy produced, that means we need to find E. Okay, we need to find E. Okay, then the question given us the T equal to 5 seconds. Then voltage V equal to 3 volt. Okay, so that means here we need to find the effective resistance here so that we can get the formula E and we can get the heat energy. Okay, so here question given us 3 volt and 5 seconds. Okay, so as mentioned, we need to find the effective resistance. So where is arranged in series? So here will be 4 plus 4, there will be 8. Okay, so what is the equation we should be choose actually? Okay, so here you can choose the equation we discussed just now, number 3. Okay, so V squared T over R. V squared T over R. So V will be 3. Then the T will be 5. And then the R here, we need to find the effective resistance 8. Okay, so then you just press calculator, then you can get your answer now. Okay, so here the answer will be 5.625 joule. Okay, and then the answer here is only given us the 2 decimal places, so you can round off to 5.36 now. Okay, so the answer here is very clear. There will be A. Okay. Okay, so before we go for our learning standard 4 and 5, so we can take 5 first. So you can continue prepare your calculator. We have more calculation question later on. Okay, so please stay tuned. Okay, hello, welcome back everyone. Okay, so now we go for our learning standard 4. Okay, so what you are going to learn here, they will be compare power and rate of the energy consumption in various electrical appliances. Okay, so here, firstly, you need to understand the definition of power rating. Okay, so the power rating of an appliance defined as how much energy is being transferred from the main to power the electrical appliance. Okay, so the power rating tell you so what is actually the energy involved so that the electrical appliance can be function well. Okay, so here the label on the electrical appliance display the voltage and electrical power required to operate the electrical appliance. Okay, so you can just look at the figure. Okay, so this is a rice cooker, electrical rice cooker. Okay, so you can see there is a label. Okay, so where showing the voltage and the power needed for the rice cooker, okay, to functioning well. Okay, so the power rating label on the electric rice cooker in the diagram is labeled as 240 volt, 700 watt. Okay, so you can just look at the data given here. Okay, so voltage will be 240 volt, and then the power here will be 700 watt. Okay, so here, what is the meanings bring to you for the power rating label showing by this rice cooker here? Okay, so here we know already just now, right? The definition for power. Okay, so this will be E over T. Okay, so E, that means this will be energy. Then T here, there will be time taken. Okay, so that means here, the label which is with 240 volt, 700 watt will be the electrical rice cooker will use 700 joule of electrical energy or in 1 second when a voltage of 240 is supplied. Okay, so you should write your answer. Write this, let's say the question asking you. So later on, we can try out one of the questions which is related to the power rating label here. Okay, then this information can be used to calculate the amount of electrical energy that is used over a period of time. So that means here the power rating label is actually can tell you so how much energy is already used within the duration here. Okay, so here the amount of electrical energy consumed can be used this formula to calculate. So where E is equivalent to energy consumed, P will be the power rating, okay, which is labor, on the electrical appliance, and then T will be the time taken here. Okay, so you can see that the formula is actually you can just using the definition of the power, where just now we mentioned already, there will be a big change of energy. Okay, so you just rearrange this formula, actually you can get again E equal to PT here. Okay, so from the formula, you can see the larger the power rating, so when the P increases now, so the more energy will be used for every second. Okay, because the E and P here is actually direct proportional. Okay, so the longer the usage of time, the more electrical energy will be consumed. Again, you can see the relationship between E and T is also direct proportional. Okay, so now we already understand what is the power rating. Okay, so this is actually related to the cost of electric energy we are going to calculate. Okay, so here first, the amount of energy, the electrical energy consumed, E, we can using the formula just now I mentioned to you, E equal to P times T. Okay, but here, the power unit we are involved here, we have to change to kilowatt and not watt. And then the time involved will be using hour, not second. Okay, so that the E will be kW times H. So the unit for the E here will be kilowatt hour. Okay, so where stated very clear already. Okay, so the P we using unit of kilowatt, and then time must be used in hour for our calculation. Okay, so the unit of the measurement we use kilowatt hour. Okay, so the BM will be kilowatt jam lah. Okay, so we can actually converting 1 kilowatt hour to SI unit. Okay, so the 1 kilowatt hour is actually represent as 1 unit when we want to calculate the cost of electrical energy going to pay. Okay, so here if we change the 1 kilowatt hour to SI unit, so SI unit will be watt. 1 kilowatt will be 1000 watt. So 1 hour will be 3600 seconds. So that means that 1 kilowatt hour will be equivalent to 3.6 times 10 power 6 joule. Okay, so here will be the definition for 1 kilowatt hour. Okay, so from the formula, we are very clear that so the 1 kilowatt hour will be the energy used by a 1 kilowatt electrical appliance for 1 hour. Okay, so for calculation, the cost of electrical energy, this is a formula we are going to use. So units of electricity in kilowatt hour. So that means here 1 kilowatt hour will be represented as 1 unit lah, and then times cost per unit. So the cost per unit will be given by the question. Okay, so here let us try together one of the questions related to Learning Center 4. Okay, so this is a question from 2018. Okay, so diagram 26 show a bulb that has a specification. Okay, so again, you can see here we have the information given 240 volt, 60 watt. So this is actually the power rating label, which you may see on most of the electrical appliances now. Okay, so what is the electrical energy consumed? So again, we actually want to find the value of E. And then in 5 hours, so T will be 5 hours. So in the unit of kilowatt hour. Okay, so the question given us 240 volt, 60 watt. So the watt here showing that this is actually the information given for power. Okay, so in terms of kilowatt hour, so we have to change the watt to kilowatt hour. That's to kilowatt. So that means we need to divide 1000. Okay, so again, we're using this formula. Information given us, P equal to 60 watt. So we have to change to kilowatt. Okay, so we 60 over 1000. So we get 0.06 kilowatt. Then we substitute into the formula. Okay, so again, just now we mentioned already the time taken, 5 hours. So we have to using hour, not need to change to SI unit. Okay, so after that, we get our energy in kilowatt hour will be 0.06 times 5. So we get answer will be A. Okay, so clear everyone? Okay, so we go for next question here. The question is from 2018. Okay, so this is actually the partial question which is related to subtopic of today. Okay, so diagram 8 shows an electric stove which uses heating elements made of wire. So the electric stove is labeled as, again, so here 240 volt, 2 kilowatt. This is a power rating labeled on the electric stove. Okay, so what is the meaning of 240 volt 2 kilowatt. Okay, so this is the power rating value where bring you what information. So just now we also explained it, how you have to give this type of answer, right? So you have to relate your power to this equation. When is the definition of power? Rate change of energy. Okay, so that means here they will be involving 200 joule of the energy in 1 second when 240 volt is supplied. Okay, so let us go through the answer here. So you have to change the answer as this from the power rating to this sentence. So the electric stove used 2000 joule of electrical energy in 1 second when a voltage of 240 volt is supplied. Okay, so you can maintain your answer of 2000 joule to 2 kilojoule is considered also the same. And so this will be the first mark. Okay, then the next will be calculation question. Okay, so the question will be like this. Okay, so the electric stove is used for 5 hours per day. Okay, calculate the energy used in unit kilowatt hour for 30 days. Okay, so that means here firstly we need to find kilowatt hour, right? So we need to use the power rating. Okay, so E equal to PT. We discussed already, we're using this formula. Okay, so just now we also discussed already the power rating label, 240 volt, 2 kilowatt. Okay, so that means the power is given by the power rating already. So when equivalent to 2 kilowatt. Okay, so please maintain in kilowatt as we want to calculate the energy in terms of kilowatt hour. Okay, so 5 hours per day for 30 days. So that means here we can okay, sorry. Okay, so we need to change 5 hours times 30 because we want to calculate for 30 days Okay, so here this will be the equation. P and T here. 5 hours times 30 so we get 300 kilowatt hour. Okay, then the next here will be if the cost if the cost of electrical energy is 20 cents per unit. So just now we also discussed already. 1 unit will be equivalent to 1 kilowatt hour, where also given by the question already. Okay, so what is the cost you need to pay? Okay, so the 300 kilowatt hour unit will be also 300 Okay, so this is the formula we are going to use where unit or electricity use times the cost. So here will be 300 times 20 cents. You have to change the cent to RM. Will be like this, 300 unit times 20 cents. Okay, so the answer here will be 60 ringgit. Okay, so 2 marks. The first mark will be given for substitution. Second mark for the answer with correct unit. Okay, should be not very hard. Okay, so here will be the more complicated question. Okay, so where is the example question from 2015. Okay, so this question want ask you to calculate the total bill you have to pay. Okay, so let us go through the question together. Okay, so as a consumer, we are charged for every unit of electrical energy consumed by a sequence rate as shown in diagram 28 issued by TNB. Okay, so this will be the rate involved. You can see here for the first 200 kilowatt hour, that means first 200 unit. So 1 unit will be paid for 28.80 cents. Then the next 100, there will be 201 to 300 unit. So you have to pay 33.40 cents and also others. So that means here we need to find out what is the total energy in terms of kilowatt hour we use now. So in the units of kilowatt hour we use. Okay, so the table 1 shows the informative list of electrical consumption of consumer in the months of April 2014. Okay, so you can see here, aircon will be 1, the power is 1,000, and hour consumed in month, 180. Okay, so using table diagram 2.8, diagram 28 and table 1. Okay, so how much does the consumer have to pay the electric bill in April? Okay, so here, as I mentioned to you, we need to find the energy consumption for every appliance now. So we're using again the formula we learned already at lesson 4, E equal to P times T. Okay, so here, April, we have 30 days. However, you can see here, the table given us is actually hours in month already. Okay, so not the hour in day. Okay, so that means we don't need to bother how many days for April in case the question asking you or the question providing you the hour consumed in a day. So the answer at final you have to times 30 days. Okay, so this is just a reminder for you. If the question given you the hour consumed in a day, not a month. However, here we don't need to bother. We don't need to bother of this. Since the table here given is a usage for a month. So we can just straight away using P times T. Okay, so again, the reminder here, there will be power. You need to change to kilowatt. Okay, and then the time we have to using hour. So this is no problem because it's already in hour. We just need to change the watt to kilowatt by divide 1,000 now. Okay, so the first will be quantity of 1. Okay, so here will be P in kilowatt hour. Now we divide 1,000, and then this is in hour already. So there will be 180 kilowatt hour for the first appliance now. Okay, then you have to continue calculate one by one. So the question here is more complicated compared to previous one. Okay, so the second one, again, we're using same formula. So the one here referring to the quantity only got 1 for the water heater here. So the power have to change again to kilowatt. And then the hour use will be 60. So finally we get 60 kilowatt hour. Okay, so here the length here we have 6. So we need to 6 times 40 divided 1,000, 10 times 200. Okay, so it'll be like this. 6 times 40 over 1,000 times 200. So you get 48. Then the next here will be the food blender. So we're using the same method. 1 times P. So P have to change to kilowatt by divide 1,000. Okay, and then times 30, which is hour consumed in April. Okay, then the fan here we have 4. So we are using 4 times 60 over 1,000 times 100. So we get 24. So we add on all the energy in a unit of kilowatt hour. Okay, so that we get the total energy use will be 313.8. Okay, so as mentioned, we have to follow the rate given here. The first 200 will be using 21.80 cents. Next 100 will be using 33.40 cents. And then the balance we have to using 40. So where here stated already is 301 to 400. Okay, will be 40 cents. Okay, so that means here we can change, we have to classify to 3 parts. First 200, next 100, and then the balance will be 13.8 for the third range now, which is between 301 to 400. Okay, so here, the first 200 will be using 200 times 0.2180. Okay, to change to ringgit. You see, I changed the 21.80 cents to ringgit already. So I get 43.60 cents now. Then the next second 100 will be 201 to 300. So our value here is 313.8. So the next 100 we have to pay 33.40. Okay, so again we have to change to cent. So I get 33 ringgit 40 cents now. And then the balance will be left 13.8. So they will be at the third range with 40 cents per unit. So it will be 13.8 times 40 cents. So we get the value 512 cents. So the total bill you have to pay, you just add on everything lah. Okay, so you just add on everything. Okay, so you get 82.52 ringgit now. Okay, so this is answer. Answer is D lah. This is one of the questions they may ask you, okay, for Learning Standard 4 or subtopic 3.4 today. Okay, so the last here will be the Learning Standard 5. Okay, so suggest where to save usage of electrical energy in household. Okay, so here we have to discuss how we can save our energy. And then at the end of this Learning Standard 5, we have another formula. Okay, so where we want to get the efficiency of the certain electrical appliance. Okay. Okay, so where of increasing energy efficiency. Okay, so here actually we have many methods. This is just some of the example I show you today. Okay, so first, switch off all the unnecessary lights. Use low power lamp and install phone screen lighting where is acceptable. So that means we're using low power usage of the bulb here. Then the second, okay, so regularly cleaning and removing dust from the air filter of air conditioner and blade of the electric fan. Okay, so this is another way, so that we actually want to reduce the load where it comes from the dust. Then the next here, use 5-star. Okay, so you can just look at the label of the electrical appliance here. Okay, so you can see here is labeled with 5-star. Okay, so the 5-star rating electrical appliance should be used because they will be more efficient and more energy can be saved. Okay, and then the next here, use full load of the washing in a washing machine. Then the next here, there will be do not put warm food into a fridge or freezer. Okay, so that means the freezer need to use more energy to reduce again the temperature to the temperature we set now. Okay, so that means the energy will be used more when we put hot food inside the fridge. Okay, then the last reference answer here will be improve the airflow and ventilation. So that means here it will be save energy to on your aircon. Okay. Okay, so here there will be the calculation involved in Learning Standard 5. So it's the efficiency of the electrical appliance with the unit symbol. Sorry, with the symbol of this now, just like N. Okay, so the efficiency of all electrical appliances is less than 100%. Okay, so because not all energy input is converted into useful energy output, as per mentioned just now, right? So the energy can be lost at heat, especially when we transferring our electric with more higher value of current. Okay, so you should reduce the current flow when we transferring our current, especially from our power generator. Okay. Okay, so here will be the first formula involved for calculation. Okay, so the E naught here represent the energy output of the useful appliance. Then the EI here represent as the energy input of the useful appliance. So you times 100%, then you may get the efficiency of the electrical appliance. Okay, so hi Jimmy. Okay, so thank you for staying together with me here. Okay, so we have few more questions going to discuss. Please involve yourself also. Okay, then the second formula for calculation here will be using PO over PI times 100%. So the PO will be power output, then the PI will be power input again times 100%. So that means the efficiency, the answer must be given in percentage. Okay, so here will be the question number 10. Okay, it's from 2012. So the question will be like this. An electric motor device has the input energy of 200 joule and out energy 180. Okay, so very clear that the 200 here is represent as input energy EI lah. So when the symbol we discussed already just now, right? Okay, and then the out energy, there will be EO. Okay, so the which statement is correct here? So you need to find out the percentage of efficiency for this device, and then the energy changes here. Okay, so here, this is the electric motor. Okay, so motor will be changed to kinetic energy. So here will be electric to kinetic. Electric to kinetic. Actually, it's very clear. Suppose will be A, right? Okay, so however, we need to double confirm by using the formula we learned just now. Okay, so there will be E naught over EI times 100. So we just substitute the value we discussed just now. Okay, 180 over 200 times 100%. Okay, so you will get 90. So we are already confirmed that the answer here will be A lah. Okay. Okay, so we go to our last question today. So this is actually the section B reference question. Okay, so I just take the question which is related to subtopic today lah. So this is a question between 2016. It's a question 2016 and 2009. Okay, so the question A and C is actually the actual question for SPM 2016 now. Then B and D will be 2009. Okay. Okay, so diagram 12.1 show a bird patching on the high voltage cable that transmit electrical power to consumer. Okay, so the first asks you the definition of power. Okay, again, just now I already tell you, you can using the formula for the definition now. So the E here will be energy, T will be rate. Okay, so the answer here will be the rate transfer of the electrical energy. Okay, it's very easy if you can just converting the formula to the definition here. Okay, then the second here is normally the theory question. Okay, so here normally will be 4 marks. So this will be the B1, 3 marks question. Okay, so diagram 12.1 shows the graph for potential different V against I for filament lamp. Okay, so based on graph, set the relationship. Okay, so firstly, you need to set relationship between the V and I. Okay, and then what can you conclude about the resistance? Okay, so what is the relationship you can get through this graph? Okay, and then give a reason. Okay, so this actually is a graph from subtopic 3.1, or where you actually can get information from this table. Okay, so here there will be ohmic conductor and non-ohmic conductor. So here definitely you can see the graph. There will be non-ohmic conductor, right? As a graph V against I is not a straight line. Okay, so that means the length here will be not obey the Ohm's law. Okay, the relationship here is very clear. There will be V increases with I. Okay, and then the resistance will be increases now. So when this is the info request by the question here. Okay. Okay, so here we should follow the information from Ohm's law. Okay, so first the relationship V and I, there will be V increases with I. Okay, so this is the first. When I increases, V increases. This will be for the first mark. Okay, then the next how you can make your conclusion about the resistance. Okay, so the resistance here given increases. Okay, so for Ohm's law, we know already. Okay, so V equal to IR. So R will be V over I. So that means the gradients of the graph will be showing as the resistance. Okay, so R equal to V over I, which is the gradients of the graph. Okay, then you can see this is the initial value of R, where you can get by calculate the gradients. So it's smaller. Okay, then the resistance for the final, they will be higher. Okay, so that means that the graph showing that the resistance is increases, where is meet the info from the textbook here. So here as current I increases, gradients increases. Okay, so you need to tell the reason. Okay, so the reason here will be resistance increases as temperature increases. This is a characteristic for non-ohmic conductor. So here will be the reference 4 marks for this B1. Okay, and then the next question, number 2. So the question here is related to our learning center, our subtopic 2.4 today. Okay, so what happened to the energy dissipated in the filament lamp when the current flowing is decreases? Okay, so now you need to state the energy is increase, decrease, or remain the same when the current decreases. Is I. Okay, again, you can explain your answer by using the formula. So the formula is a formula where we learn already at our learning center 1 today. So this will be E equal to VIT. So now we need to find the relationship between E and I. So we are very clear that they will be direct proportional. Okay, so when I decreases, the E will be decreases. Okay, so this is how you can answer this question. Okay, and then the next here will be the 10 marks question. Okay, so this is an example question I take from 2016. Okay, so which is related to our learning, our subtopic today. Okay, so the question will be like this. Diagram 12.2 shows the design and characteristic of 4 different circuits. Okay, so here we have J, K, L, and M. Okay, we have 4 circuits here. Okay, so stability for each design and characteristic of the circuit and determine the most suitable circuit to enable the electrical appliance to work efficiently. Give reason for your choice. Okay, so for this question is actually the decision-making question. Okay, so you may type your answer, which is the circuit suppose we need to choose in the chat room. Okay, so advise the answer in table. Okay, so here 10 marks question and then ask you to choose the best one. So that means you need to find the 4 aspects from the figure and give 4 reasons. Choose which is the best circuit and then copy again the aspect or characteristic you choose lah, at the first until the 4th one here. Okay, so from here we need to observe what is the 4 characteristic we need to select. Okay, so we need to observe what is the 4 differences between these 4 figures. Okay, so firstly, you can see that already labeled in red box here. So the wire, okay, we have two type of wire. Okay, so thick wire or thin wire. Okay, so which is a better one? Okay, so for sure that now we want to allow the current flow through the circuit and reach the appliance. So we need to choose the low resistance, right? So we have to choose the thick wire. Okay, so that means the thin wire will be out already. So the L and N should be out already. We just need to focus the circuit J and K. Okay, so the first we will be choose the thicker cable, thicker wire. Reason, low resistance, or you can give also more current will be flow through also is correct. Okay, so this will be the first. Then the second, you can observe again. So now we just need to focus on J and K already. So another 2 is already out. Okay, so you can see here. So the circuit J is connected in series, while circuit K is connected in parallel, right? You see, they have more route to reach the respective appliances here. Okay, so here we have 2 types of circuit. Okay, so one is series, another one is a parallel. Okay, so which we need to choose. So we need to choose the parallel circuit, right? You learned already at the subtopic of 3.2. Okay, so you have to give the advantage of the parallel circuit. Okay, so again, we choose the parallel circuit. So that means we are very clear that the circuit K suppose need to be selected now. Okay, so parallel circuit is chosen. Reason, so effective resistance is lower, so that more current will be flow through. So this is one of the reference answer for you. Okay, so another one we know already. So if the appliances is arranged in parallel, if one of the appliances is 40, another appliances will be still not affected. Okay, so you just need to give one of the advantage for your answer now. Okay, and then again we already ratio that will be okay. So another 2 aspect will be, what will be the difference? So you can just observe again the figure. So you can just look at the power rating for the both appliances here. Okay, so you can see here with 240 volt, 2.2 kilowatt. The toaster will be 240 volt. Okay, so you can see for the main supply for the circuit J, 200. K will be 240. Another 2 figure will be 240 and 200. So from the power rating, we are very clear that we need to choose 240 volt for the power supply here. Okay, so we need to choose 240 lah. So the 200 is already. Okay, so high voltage of 240 volt is needed. So here you need to give the value lah. Since different value might not give the effective operation for the kettle and the toaster, which is power rated with 240 volt already. Okay, so both appliances have power rating of 240 volt now. And the last here, you can observe that the fields is also different. You need to choose 15 and 20. Okay. So for this, you need to calculate the total current we need to flow through these two appliances. Okay. So we're using this formula P equal to VI, and then we rearrange I equal to P over V. Okay, so the total current, okay, we're using P 2,200 for cattle over 240. And then for toaster, there will be 2 kilo over 240. So, and now we get 17.5 ampere. Okay, so the 15 ampere is too low already. Okay, so the current flow with 17.5 ampere will cause the fuse to melt already. So we have to choose the rating is slightly higher than 17.5. So that means here is very clear that we need to choose a fuse of 20 ampere. Okay, so a fuse of 20 ampere is needed. So normally we will choosing higher and lower, right? But this question will be exception. So you have to give the value of power rating, which is 240 volt voltage, and then for the fuse, you have to choose 20 ampere. You cannot give lower or higher here. Okay, so the reason here is very clear that there will be total current flow the total current flow will be 17.5 ampere. And you should choose, you can also showing your calculation in your answer here. Okay, so here we choose circuit K lah. Okay, and then you have to copy again. So thicker cable will be used, parallel circuit is chosen, high voltage of 240 volt is needed, and then a field of 20 ampere is needed for your marks number 10. Okay, so then here will be the D last calculation question here. So diagram 12.3 shows the energy saving bulb. So when it is connected to 240 volt power supply, the bulb produces 10 joule per second of light energy. Okay, so the question first asks you to find the current flow. Okay, so current flow, then the question given us power rating. So which is labeled with P equal to 11 watt. V equivalent to 240 volt. So PV and I, what's the formula we should choose? So just how we learned already. So we should choose P equal to VI. Okay, then we rearrange to become I equal to P over V. You just substitute the value 11 over 240. So you get 0.046 ampere. So make sure you give minimum 2 decimal places with correct unit for your final answer. Okay, then the second, the question asks about the heat energy loss in 1 second for the bulb. Okay, so energy in 1 second, that means the power lah. You have to refer power first lah. So here the question initially given us already, the bulb produced 10 joule of the light energy. So that means there is a loss of the power here, right? So since the power rating given is 11 watt. Okay, so the power rating show the total power of the bulb is actually 11 watts. Okay, so this is an input. This is an input power. Okay, so therefore the energy used in 1 second will be 11 joule. Or you let's say we follow the power rating. Okay, and then the information given in the question, 10 joule per second of light energy is actually the power that changes into the light. So where is 10 watts? Then this is the output power. So that means in 1 second, they will be producing 10 joule energy. So the heat energy loss is actually 11, which is input energy, minus the output energy, which is 10 joule. Okay, so the answer here will get 1 joule. Okay, then the last question here, number 3, you need to find the efficiency of the bulb. Okay, so this is a formula where we learned already at Learning Center 5, right? Okay, so here the question given us the output power, which is 10, and the input power is actually 11, where you get from the power rating. Okay, so you have to just substitute in this formula lah. So you get your answer 90.91%. Okay, so this will be the sample question of section B, which is related to subtopic today. Okay, 3.4. Okay, so that's all for my sharing today. Okay, so thank you everyone for stay together with me until now. Okay, so now I have to share you the link schedule. Okay, so please stay at the comment because I have to send you the let me send you the link schedule. Okay, so the link schedule already sent to the chat room. Okay, so you may fill up the link with the any email you are available. Okay, so please fill in within the 30 minutes or when the live is just in now. Okay, so thank you also Jimmy for stay together with me here. Okay, so that's all for my sharing about the lesson or subtopic 3.4 today. So please click like and share the link of lesson today for your friends so that more of your friends can benefit from my lesson today. Okay, so again, please do not forget to follow the next physics lesson where the Form 4 lesson will be conducted by Cikgu Rosemawati. Okay, they will be go for subtopic 3.2, Hukum Kepler, okay, for non-DLP group. And then for the Form 5, physics will be as usual. Okay, so the next lesson will be conducted by Cikgu Hasnitah. Okay, then the subtopic will be chapter 4, okay, electromagnetism, okay, subtopic of 3.1. Okay, so that's all from me. Okay, so thank you everyone for joining my lesson until now. Okay, so please stay together with IU Physics group. Okay, so see you all next time. Okay, so bye-bye.